Once again, we are talking about evaluating trig functions. This time, we're talking about a special kind of angle. These are quadrantals. Now, we've talked about these in the past, but I'll just reiterate again. Quadrantals are angles that their terminal side ends on either the x or the y axis. So an example of that would be 90 degrees, or it could be 180 degrees, or 270 degrees, or 360 degrees, so on and so forth. It's going to be any multiple of 90 really is going to give you a quadrantal. Now, in order to evaluate these, so for example, if I had said, what's the sine of 90 degrees? Now, we've been used to doing that with reference angles and drawing those reference triangles, but if I have a value right here at 90 degrees, well, I can't really draw a triangle with that because it's right on that y-axis. So we're going to use a slightly different approach for these. What we're going to do, and the reason why I have this circle here, imagine I drew a circle, rotated all the way around 360 degrees, and the radius of this circle was 1. So that means any point where this circle hits either the x or y axis, I can label that with a coordinate. So for example, again, if the radius is 1, here my x value would be, I went to the right, 1, and I didn't go up or down at all, so my y value would be 0. So that point right here would be 1, 0. Here, my x value is 0, but I've gone up 1, so it would be 0, 1 would be that coordinate. For this, my x value went to the left would be -1, y value would be 0, and last but not least, down here at 270, that would be 0, -1. So I'm going to use those coordinates to help me evaluate some of these functions. Now, when we've drawn a triangle to do these, we've been thinking about our trig ratios in this sort of fashion with what's the opposite side, what's the hypotenuse. But think of it this way, if I don't have a triangle, I can't really think about a hypotenuse or an opposite or an adjacent leg. So what we're going to do is we're going to kind of set up these ratios slightly differently using x and y values from these coordinates. So our sine of theta, we're used to saying opposite over hypotenuse. What we can also look at that is the y value over the radius. Now, the radius in this, like we just said, the radius is always going to be a 1. Cosine, it's going to be the x value over the radius, which again is always 1. Tangent is going to be the y value over the x value. And then for our reciprocal functions, well, I'm just going to take the reciprocal of these, right? So instead of hypotenuse over opposite for cosecant, it's going to be the radius over the y value. This will be the radius over the x value. And lastly, it'll be x over y for cotangent. These are the ratios that we're going to be using for quadrantals. So again, anytime you see those quadrantals, those are the ratios that you're going to be looking to use. So let's kind of see this in action. So first up, we're going to actually find all 6 trig ratios using the same angle, just so you can kind of see how it can progress here. So I happen to pick 90 degrees. Again, it could be a different quadrantal. So for sine of 90, I know that I'm looking at this coordinate right up there, right? Because that's the one that corresponds with 90 degrees. So for sine, I know I'm looking at the y value divided by the radius. So the y value for this coordinate is a 1. The radius is a 1. And obviously, I'm not going to leave my answer as 1 over 1. My answer is 1. So here's our first one. Now, cosine of 90, again, I'm still using this point, still using that coordinate for 90 degrees. Cosine is going to be x over r. The x value of this coordinate is 0 divided by 1. 0 divided by anything is going to be 0. Next up, tangent of 90 degrees. So tangent is going to be y divided by x. So the y value is 1. The x value is 0. Anything divided by 0 is going to be undefined. Now again, don't say 0. Don't say that there's no solution. It is undefined. Again, anytime you see 0 as that denominator, it's going to be undefined. Now, cosecant is going to be r over y. So 1 is the radius. Again, the y value is 1. 1 over 1 is just 1, as we know. Secant. Secant is going to be r divided by x. So 1 divided by my x value is 0. That is going to be undefined once again. Again, totally fine if you abbreviate it. And then cotangent of 90. Cotangent is x divided by y. So 0 divided by the y value is 1, which gives us 0. Right? 0 divided by 1 is just 0. Okay, now, again, we could do this for any of these other coordinates. We could use this one if we're given 180. We might have used this coordinate if we're given 270. Now, this was degrees, but the same thing can also be done for radians. So that's what we're going to look at now. So, same as before, I'm going to use the same angle. I'm just going to use pi, and we're going to do all 6 trig ratios with that. So, now, this time, let me find a different color. Let's use blue. Pi is the angle that I'm interested in. Now, I had labeled these with degrees. We can go back in and label them with radians again. Again, if I'm rotating around in radians, it'll be pi over 2. This is pi. This is 3 pi over 2. And this is 2 pi. Again, so on and so forth. Just instead of adding 90 degrees, you're adding half pi every single time. So if I want pi, right, that's over here. This is now the coordinate I'm going to use for all of these. First up, again, we'll do sine. So sine of pi, sine is y over r. The y value this time, last time the y value was 1, but now the y value is 0. So this is 0 over 1, which is 0. Again, that radius is always going to be 1. Cosine is x over r. So this time the x value, negative 1 over 1, simplifies to negative 1. Tangent is going to be y over x. So 0 divided by negative 1 is going to be 0. Cosecant is r over y. So the radius is 1. The y value, again, of that coordinate is 0. So that is going to be undefined, right? Can't have 0 in that denominator. Can't stress that enough. Secant is going to be r, which is 1, over x. X value is negative 1. 1 divided by negative 1 is negative 1. And last but not least, cotangent of pi, x over r, x value, negative 1 over, sorry, not over r, x over y for cotangent, negative 1 over 0 is going to be undefined. Now, you might see from here, because we're just combining all these ratios, all these fractions, I'm combining zeros, ones, and negative ones. So my answers are going to be one of these things that you see on the page right now. It's either going to be positive 1, negative 1, 0, or undefined. For these quadrantals, when you're evaluating them, there are no other options. Again, what's important, again, whatever angle you're given, find where that would be if you rotate it around, pick that coordinate, and go from there. Now, something to just keep in mind, again, and if you want to draw kind of your x and y axis for each one to sketch out your picture and pick the right coordinate, that's totally fine. I might give you angles that are more than 360 degrees. Like if I did 630 could be one that you see, or 720. And you could also have negative angles. I might give you negative pi over 2 or something like that. So make sure you're rotating in the correct way and picking the right coordinate to use to fill in these trig ratios.